All right. Hello, everybody. Welcome to a practical guide to Kubernetes policy as code. I'm going to skip the agenda. You'll see it. It's coming. I'm Andy Suderman. I'm the CTO at Fairwinds. I'm also a co-chair of the policy working group. I'm joined here by Joe Betz, a staff engineer at Google, who is the SIG-API-Machinery lead, Rita Zhang, principal engineer at Microsoft, who is the chair of SIG-Auth, and the founder and CEO of Nirmata, Jim Bugwadia, who is a co-chair of the policy working group with me and a maintainer of Kyverno. We're here to talk about policy and policy as code. So first of all, why should we care about policy? This is a very simple graph from one of the white papers that the policy working group has put out. But basically, what we're trying to say here is that policy underpins just about everything that you might care about in your Kubernetes cluster. We're going to talk a little bit more about that and then dive into some specific examples of different policies. Recently, Jimmy Ray, another member of the policy working group, wrote a book called Policy as Code. We say he wrote the book these days. And he said, it is the use of code artifacts to manage and apply rules and conditions. It's a pretty simple definition. I think we can all wrap our heads around that. But if you look across the Kubernetes code base, you'll see that there's policy in many, many different parts of the code base. RBAC is policy. We have validating and admission policies. We have authn and authz, which are types of policies. We have network policy. We have kubelet configurations. We have quotas, limit ranges, resource quotas. We have all these different things that are policy. We don't have time in 30 minutes to cover all of those today. So we're just going to cover a small portion of those in the next few minutes. But why should we do policy as code? Why shouldn't we run individual programs to enforce policy? And really, it's just all the reasons that we care about doing things as code. It's very similar to infrastructure as code. It's more maintainable. It's more efficient. We can all inspect it together. We can do code review on it. We can see how policy is working within our system. And Kubernetes provides a lot of different patterns for this. We have policy enforcement points already built into the code everywhere. So with that, I am going to, apologies. One more quick disclaimer. Again, we're not going to cover all the different projects available. There's lots of entry options. There's Gatekeeper, there's Kyverno, there's KubeWarden, there's Polaris, there's JS Policy, there's Cloud Custodian. I probably missed 6 different projects. Again, we don't have time to cover all of those today. So instead, I'm going to hand it off to Joe, who's going to talk about.
I'm going to talk about policy within Kubernetes. Thank you, Andy. So within Kubernetes, policy has been kind of available since about the 1.8 release when we introduced admission webhooks. And this was kind of the foundational extension point that you could use. The way it works is that you can intercept all write requests coming into the control plane, and that gives you the ability to control what is happening in your cluster. But you do that in a very general way, right? Like you build this new binary, which becomes part of a control plane. And it's really a critical component of that control plane because it's part of the request serving flow. So if it becomes unavailable, your control plane becomes unavailable. And so you, as a extension author, you have to take that really seriously. You have to think about, well, how am I going to develop this thing? How am I going to maintain it? What's the upgrade plan? Is it going to scale to the needs of all the clusters it's installed in? All the things, monitoring, everything that comes along with having a critical component. And what we saw in the ecosystem since 1.8, which is a long time ago, is there's been a lot of problems with admission webhooks in clusters. I've seen that in GKE. We've seen it in the ecosystem at large. And when we started to look at this problem and ask, like, how can we help the ecosystem do better here? How can we make the webhook problem less of a problem for the community? One of the things that we observed was that the vast majority of webhooks were doing really simple stuff. And it was kind of this 80-20 split where oftentimes you would have somebody that wanted to build a CRD and a controller, and they didn't really want to build a webhook, but they ended up having to make one because they needed to enforce a bunch of validation rules at the front door. And so from that came this observation of like, well, is webhooks really the right solution to that kind of problem? I mean, logically what they're doing is they're putting this little bit of custom logic in that does some check, and if the check's false, they don't want to let the request into the API server. But if it's really simple logic, why not just put it straight into the Kubernetes API server in the first place? And so we looked into how to do this. We looked at WASM. We looked at a bunch of different embeddable programming languages. And the one that we found that we really liked was called the Common Expression Language. And there's kind of 3 properties we liked from this language. The first was that it was designed to be embedded into things like YAML. It's designed to be these kind of single-line expressions. The second thing we really liked about it is it was a relatively unsurprising C-style syntax. So if you've worked in modern programming languages, you're probably going to be able to figure out what this code does, and you're probably going to be able to write it without having to be taught how to do it. And then the last property, which is really important, is that Cell has a relatively low overhead for execution. So you're talking like 5 to 10x of native code, but we still get runtime safety. So we still get to bound the running time and the memory utilization of the Cell programs that are run. So here is an example of Cell being used in Kubernetes. This was the first feature we added Cell for. It's called CRD validation rules. And the way that this one works is that you're allowed to add Cell expressions into your CRD schema to perform more complex validation. This is a cross-field validation where you're checking 2 fields. You can also do update validations like immutability checks. This has been really successful. So large projects like API Gateway have been able to use this to completely migrate away from a webhook and use only code in their CRD to enforce all their validation rules. All right, so that's kind of interesting, but I haven't really talked about policy specifically. And so that gets us to our more recent features. The first one is called ValidatingAdmissionPolicy, and this is a direct substitute for an admission webhook. So like you can have a validating webhook configuration, you can have a validating admission policy. So somewhere in here, there's got to be some Cell, right? So if you look to the left, the main resource under the spec validations expression, that's where you'll see the Cell expression. This is an entirely self-contained policy. You don't need to write any separate binary to load this into your cluster. So once you've loaded the policy, which is usually authored by some kind of policy or extension author, then your cluster administrator, which is a separate role, typically will bind that into their cluster, which is the middle resource, and then optionally, you can also configure the policy with a separate resource if you need to. So in this case, you're setting the max replica limit to 3, and you're binding that to particular resources in the cluster. Now, like we have, usually what you're doing is you're looking at the fields in the resource, but you can additionally perform authorization checks within these expressions. So this is showing that some of the things that you can use in Cell. So a great example is imagine that you have a label that you only want certain privileged users in your organization to set or change. So you could set up a policy that does that. First, you would check to see if the label is being changed, and if it is, then you would check if that user is allowed to make that change according to some custom verb you can define. And then in your RBAC system, you just give people permission to that verb if you want them to make that change. In addition to validating, you can do mutating policy. This is currently in alpha. The way it works is the same as validating admission policy, except instead of returning a "is this request allowed" response, you're returning a patch which mutates the object. So this example shows a sidecar container being injected. You could do this way, or you could do it with a JSON patch. OK, with that, I will hand it over to Rita.
Right, and another option that has been pretty popular in the Kubernetes world is the OPA Gatekeeper project. So the project's actually, I will start with OPA, Open Policy Agent. It was actually a really popular rule engine that was donated to CNCF in, I think, 10 years ago. If you were in the keynote, you probably saw one of the logos for CNCF project, so it actually hit the 10-year mark. And back in 2018, a bunch of us actually worked together with the OPA maintainers to bring all that enterprise rule engine goodness into Kubernetes ecosystem. And Gatekeeper, you might ask, what is it, right? It's a dynamic, flexible admission and mutation webhook. Also, it has a CLI, and it's a controller that you can run in your cluster to help enforce policies. And the idea behind Gatekeeper is you write the policy once as code and configurations, and you can run it anywhere. The key differentiation for Gatekeeper is you can write it in multiple languages. It started as Rego because that was the default language in OPA. And then recently we added cell support because, again, we want to make sure you can write the language of your choice. And today it might be Rego, cell, who knows what it will be tomorrow. And also with that, it also works with multiple engines. Again, OPA, obviously, and then Kubernetes VAP, as Joe mentioned. And last but not least is multi-target. And the idea is the same code that you use for Kubernetes admission, you can use it for Terraform, you can use it for other type of target. So Gatekeeper is a target for Kubernetes admission. And another big difference for Gatekeeper is separation of concerns. When we worked with organizations, a lot of times the people who write the policies are often different from the people who are actually deploying the policies. And therefore, we created this solution that basically allows different persona to manage different type of resources. For example, if you're rolling out the policies, you might care about the specific parameters that you put to actually do the enforcement. And so that resource is called a constraint. And it's decoupled from the logic where the people who write the policies will actually write the rules. And again, this ensures that the policies can be configured and not, instead of actually focusing on writing the code. And then also, Gatekeeper, because it started a long time ago, we have a good community that actually contributes a lot of the policies that you can use right away. And it's a Gatekeeper policy library. In fact, when we were deprecating PSP in the early days, Gatekeeper library was used to help users migrate. OPA was graduated in 2021, and there's a lot of contributors from many companies like Microsoft, Google, Red Hat, Styra, VMware, and many, many more. And I'm sorry if I forgot to mention you. So you might ask, VAP is great and MAP is great because it's more reliable. So what are the differentiation? When should I use Gatekeeper, right, or any other webhook for that matter? So I'm not going to mention the ones that they do the same things. So for example, for audit, let's say you want to audit existing resources and you want to stream that data somewhere else in your in enterprise management system, say for tracing or compliance reasons. This is where Gatekeeper can do that. And it basically provides a history of the violating resources that are currently in the cluster. And also shift left, right? We know that developers would much rather enforce these policies in their code. And this is where we have a CLI called Gator. You can actually run it in your CI/CD pipeline, and it will actually can be used to test your policies as well as the resources that you plan to deploy to your production cluster. And then there's also metrics, right? It already comes with Prometheus metrics. And then there's another concept of context awareness for things that are already in the cluster. So think of the scenario where you want to detect uniqueness of your ingress resources. This is where you can, again, create a Gatekeeper policy that allows you to do that. And then external data sources, let's say you want to talk to an external data source in your policy, you can also do that. And then last but not least, PubSub. Let's say you want to subscribe to violations and you want to stream that somewhere else. That's another feature that Gatekeeper does well. So in terms of how does it work with VAP, as Joe mentioned, the concept behind Gatekeeper is we do not want to compete with VAP. We love VAP, okay? And in fact, we want to be the front end to unify the experience for the user. Meaning we want you to write your cell expressions in one place, and Gatekeeper will actually manage both VAP for the common use cases and non-VAP for the more advanced scenarios where you have to use a webhook. And because we have multiple language support, you can write in the language of your choice. And and it will basically generate the VAP resources for you so that the in-tree Kubernetes emission controller will actually do the enforcement. Meanwhile, for non-VAP advanced scenarios, that would actually be handled by the Gatekeeper webhook. And again, this is to, especially for big teams, you can use this solution to share your policy definitions across both VAP and more advanced features like audit and referential checks and external providers. So here's an example of what a Gatekeeper constraint template looks like. And as you can see, you can actually provide multiple engines, one for Kubernetes validating policy, and that's the cell expressions that you see. And then another one is Rego. Again, you can write it in the language of your choice. And then for mutation, again, because it's a webhook, there's a bit more overhead. And therefore, for basic mutation features, we highly recommend that you use the in-tree map feature in Kubernetes. But for the more advanced scenarios, like calling out to an external data provider, this is where Gatekeeper shines. Why is that? Because Gatekeeper from day one was designed for global idempotency, meaning when you have multiple mutations happening at the same time or happening in different orders, different re-invocation path, the results are always the same, so it's more predictable. And it allows external data provider calls to be made in parallel. That is really, really important because anytime you add any request out to anywhere during an admission time, you're adding time into your into your Kubernetes admission request time. So this basically reduces the number of calls that you have to make to an external service, and therefore making it more stable and scalable. And you would create the resources with the Gatekeeper CRDs. And with that, I'll pass it.
Thank you, Rita. So Kyverno started about 5 years ago. So, prior to cell and validating admission and mutating admission policies, but after OPA and Gatekeeper. So when we looked at the landscape, we took a different approach to policy. So we believe policy as code is not just about validation or enforcing security, but it's more than that. It's about automation as well. It's about reducing the overload of additional controllers. So Kyverno from the very beginning has taken an approach that mutation, generation, cleanup, and also image validation should all be part of your policy toolbox. And this really is important if you're building platforms on top of Kubernetes, want to provide self-service to developers. You're going to need all of these features either through custom controllers, or you can standardize on a policy as code solution like Kyverno. So that full lifecycle management, again, is very important across all of the configurations. And when we started, the focus was just for Kubernetes. So the initial question was, how do we make it simple as well as manageable for Kubernetes admins to manage policy types and extensions without having to learn additional languages or additional complexity? So that was the starting point of Kyverno, but overall, as we progressed and as the use cases grew, Kyverno is also now able to apply policies on any JSON, any YAML payload, whether it's in your pipelines or in your API tier or pretty much anywhere in your stack. So why change, and what should we do in terms of the evolution of Kyverno as Kubernetes also continues to evolve? So first off, as these new types, like Rita mentioned, as validating admission policy, mutating admission policy, have been added to Kubernetes, it completely makes sense to delegate whatever you can to the API server, right? So Kyverno also is able to take policies written in cell expressions. It automatically generates validating admission policies and mutating admission policies so they can be run inline wherever possible. And for extensions, for other features which are Kyverno only, those will continue to run in the webhook. You also get full reporting, full other lifecycle management features that Kyverno already supports. So in addition to that, of course, it's like standard. When Kyverno started, again, we were using JamesPath as one of the languages that was supported, but we now also have full support for Cell in order to support some of these features. So with 1.14, which is the latest release of Kyverno, we're introducing 5 new policy types to continue this evolution and keep that, be as close to Kubernetes as possible, but with the right features and other extensions that are required for full policy as code. So today I'm going to just focus on a couple of these, the validating policy and image validating policy, but there are other talks and sessions, and happy to cover more at a Kyverno booth or at other discussions. So just diving into validating policy, right? And validating policy is Kyverno's flavor of the extension on validating admission policy. So the way we have cleanly abstracted and extended validating admission policy is by adding a few new tags within the declaration itself. So there's things like the evaluation mode. Whether you want to evaluate a Kubernetes resource or JSON, you would declare that. There's things like webhook configuration, which only makes sense, of course, if you're running in a webhook. So those type of things like timeouts, et cetera, you can declare there. And then auto-generation. So Kyverno from the beginning has supported auto-generation of policies for pod controllers. Now we also do validating and mutating admission policies. So that's controlled by the auto-generation. So if you look at this declaration, it looks very familiar to any Kubernetes admin who has already spent time learning validating admission policies. It's just a few extensions on top of validating admission policy, but also comes with a different cell environment. So if you do want to use advanced features in Kyverno, such as like currently, for example, if you're fetching data from image registries. So many cases, like there's use cases, you might want to call out to an OCI registry. You might want to check for the manifest configuration, and then based on that, make some policy decisions. Things like that you can do with the Kyverno cell environment. And some of this we're working with the Kubernetes upstream maintainers, like the image parsing cell functions we have written in Kyverno to promote them to upstream over time. So just comparing, and this is only a comparison of validating admission policy to validating policy. It's not, we're not going to be able to cover generating, mutating, and the other types. But just with this, the key points here are, if you need things like if you're doing background scans, because policies are not just applied to resources when they're created, but you might have existing resources, you might change policy types. So background scanning becomes really important for managing your policies. If you need fine-grained exceptions, like Kyverno has a feature to manage exceptions per image in a container, so at a very granular basis, you can control what's excluded from a certain policy and manage that separately from the policy declaration itself. And if you need, reporting, which Kyverno supports, the policy working group report format, which is a standard, which is also adopted by other projects. So if you need reporting within environments, within your namespaces, or within your clusters, those sort of things you would use Kyverno for, but it can also support, and by the way, it supports all these features also for the built-in validating admission policy, as well as mutating admission policy. Another quick example is the image validating policy. So this is where Kyverno works with both notary as well as cosign. And it can check for image signatures as well as attestations. So here, again, just keeping that same style, starting with the validating policy. So a lot of this looks very familiar. You have your validations, which are just cell expressions. But you can check things like whether an OCI image has been scanned by your scanner of your choice for vulnerabilities, whether there's an SBOM created, what vulnerabilities exist, things like that you can check, and also make sure that that image was signed by the right authorities. So all of this is supported in the validating admission policy. And the feature I really like about this is if you want to now take this and apply this to any other container image, whether it's like let's say some other managed Kubernetes service or even a serverless container image, it's a simple 2-line change to go from a Kubernetes resource to a JSON payload and to be able to apply that policy. So in summary, Kyverno is, what we have, our mission is to simplify policy management for Kubernetes, but also make that available to non-Kubernetes environments, which platform engineers will need. And we want to, make sure that policies are built in a way so developers, operators, as well as security teams can all collaborate on the same shared resources and use standard Kubernetes tooling, standard lifecycle management wherever possible to keep the learning curve as easy or as low as possible, and be able to kind of then universally use these policies, whether it's in pipelines, admission controllers in your clusters, or even in APIs against cloud services. With that, Andy's going to summarize and wrap up.
All right, so that was a lot of great info. Thanks, y'all. That was fantastic. So just to wrap it all up and give a few pieces of guidance going forward. Kubernetes Core is going to continue to support more policy as code. It's going to be there. What is there is currently very stable, and we're going to see more of it. Wherever possible, in tree, what we just talked about, what Joe just talked about, is going to be faster, more reliable, and a great baseline, but you're probably going to need something to expand beyond that. You should definitely learn Cell. If you haven't started and you're looking to do policy, Cell isn't going anywhere. I think all three of these folks just talked about implementing Cell in different ways, so it's not going anywhere. Definitely learn it. And just to outline kind of the different places where we have in-tree options and then we can expand to out-of-tree options, we have Auth-N. Structured Auth-N is in beta right now. That uses Cell as well. For Auth-Z, we have Structured Auth-Z, which is currently GA, which also uses Cell. RBAC++ is in design in SIG-Auth. See SIG-Auth for more information about that. I believe that will also be using Cell. And then we can extend that with these other projects with other webhooks for advanced scenarios. For validation, a lot of what we talked about today, we have VAP, we have MAP, and then we can extend that with additional options outside of the cluster. And then for mutation, MAP is in alpha currently. And then we, again, have extensions like we talked about today. All of that is current as of 1.33. That may, these will all start to graduate through the different stages, but as of 1.33, this is accurate. And then the last piece of advice, everybody wants to use mutation for everything. Try to keep it to a minimum. It's expensive, and it can be risky. So focus on those controllers where you can. And I think we might have a couple minutes for questions. 4 minutes. Great job. All right. Does anybody have any questions?
Hello, you all. I have a question. My name is Andre Bovendorp. I work with H&M. I would like guidance, if I have the opportunity to ask the masters here. How can I just, in a platform engineer scenario where we have a well-controlled CI and CD, how can I justify the overhead of admissions webhooks and validation webhooks in a performance scenario for cost? Like instead of using CI and CD, where the developers don't have the actual access to the infrastructure configuration, then everything is black box for them. Why use mutating webhooks, validating webhooks instead of configuring on the CI?
So if you can do something simply and quickly, you probably should in a performance scenario. If you need to punch out to a webhook because you can't express what you need to express through the built-ins, then I would encourage you to look. Webhooks now include something called a match condition, which is self-written in Cell, and you can very tightly constrain when your webhook is called. So if you do think you're going to need a webhook, but only in very specific situations, use that to very tightly constrain the calls so that you only call the webhook when you actually need it. That's probably about the best you can do.
Okay. I was wondering, with mutating webhooks, how do those tend to interact with, say, deployment platforms that are looking for diffs and trying to actively eliminate them with a new deployment? Do you just get stuck in a loop?
Yes, a good question. And there's a CNCF blog post on this topic. So both Argo CD, Flux, which are GitOps projects, they also now support server-side apply, which allows them to coexist with mutating webhooks. So it really comes down to, and like Andy was saying, it's not one or the other. There are use cases for both. So you have to pick, when you apply which tool for the right use case. All right, I think we're right on time. So thank you, everybody. And we'll be around for the rest of the week if you have any other questions. Take care.